Okay, we're in section 22. We just went through the lecture portion. Again, hopefully it made sense about what we were talking about. And we're solving equations that involve radicals now. And we have a method for it, and we'd like you to follow that method. And basically that method revolves on isolating a radical and then raising both sides of the equation to the radical's index. And we'll go through examples. We've already done some examples, but we'll do more examples. The examples to follow should illustrate the method we want you to follow, though. All right, isolate the radical, raise both sides of the equation to the radical's index. All right, so I'm going to switch screens now. And we're going to start doing it. All right. Be a short section now. Won't be much to say about this. Most equations we're going to give you are going to be really simple equations too, by the way. All right, just give me that. Got to get that working here. There it goes. Okay. So first step is first problem. Can we do it? So what do I see over here? I see a radical equation. And what I mean by that, there's a radical, and this, I see that radical symbol over here. The radical is on one side. This radical is alone on this side. What am I going to do? I'm going to raise both sides of the equation to the radical's index. Let me write that down for you. So the left side is one radical. Its radicand is this. The right side is 4. I'm going to raise both sides to the index of the radical. Now, so what's the index? The index is the number that sits in here. Now, there's no number in here, so this is implied to be 2. It's a square root function. So put that down for you. And what's nice about that, it's really simple. You get 4 squared, which is 16. And when you square that radical, you just get 2 minus x. What am I going to do now? I'm going to probably subtract 2 from both sides. And what do you get? You get minus x, 14. Divide both sides by minus 1. And you're going to get x equals 14. I'm sorry, minus 14. I'll write that down for you. Now I'm putting a box in it too, but it's premature to do that. I want to check it. And someone says, where do you check it? Up here. So what do I believe? I believe x is minus 14. So what do I get over here? I get this. 2 minus a minus 14 is 16. What square root is 16 for? It checks beautifully. The key also indicates that it checks beautifully. All right, let's go to number 2. It's really a very similar question. What I'm going to do right from the get-go is I have to isolate the radical. And the way to do that is to add 12 to both sides. So 12 to the right side, 12 to the left side. And if you do that, what do you get? You get a pretty simple equation. Get this over here. All right, what do you do now? Well, the radical now is isolated. It's alone on one side. There's only one radical there. So what do? I raise both sides to the radical's index. And this is a square root problem, so it's 2. Let's do that. We'll move forward. Well, what's nice about this is really kind of simplified. It simplifies pretty nicely. It's 2x plus 88. And 12 squared, again, if you need a calculator to do that, please do so, but I hope you don't. 144. What am I going to do now? Subtract 88 from both sides. And relatively simple to do. You get 2x. Now, what do you get there? Let's see, 88. I would give you 12. 66, right? 12. I'm sorry, 56. Wasn't thinking. All right, you get 12 and 44, 46, 56. What do you do now? Divide both sides by 2. You get something pretty simple. X equals 28. Again, I'm going to put a box in it, but I don't know if it's right. I'll check it. Where do you check it? Here. I'm going to check it. Let's see, 28, right? 2 times 28 is 56. And this is the original I'm checking it. 56 and 88. Let's see what you get. You get 94, 144. Square root of 144 is 12, and 12 minus 12 is 0. So it worked out beautifully. Right? Works out nicely. The answers are also listed for you. Let's keep going. Really almost the same question. And what do I do first? I'm going to isolate the radical. How do I do that? Subtract 2 from both sides. And what do you get? Well, you get the cube root, x minus 5 equals minus 2. What I'm going to do now, the radical's now isolated. I'm going to raise both sides to the radical's index. And what is the index? It's 3. So both sides are being raised to 3. And it's pretty simple. You get x minus 5. And minus 2 cubed would be minus 8. Now I'm going to do, I'm going to add 5 to both sides. And what do you get? You get x equals minus 3. Again, this might be premature to do this, but I'm going to put a box in this, but I do want to check it. Where do you check it? Over here. So what would you get? If I check minus 3, what do you get? I get cube root. Minus 3 minus 5 is minus 8 plus 2. And you should do simple cube roots. Now it would be minus 2. And minus 2 plus 2 does give me 0. So it does check out. Also, the answer key says it checks out. All right, let's do the next one. Not much different. And we tend to write problems that reflect what we want you to do. Very little variance on them, by the way. So if I did this one over here, let's see. The radical's isolated already. So really all I have to do is raise both sides to the 5th power. I'll write this down for you in steps. So it's the 5th root of 3 minus 7x equals minus 2. I'm going to raise both sides to the index of the radical, which is 5. So I'm going to put 5 down. And what would you get? You would get 3 minus 7x equals, let's see, minus 2 times 2 is 4, minus 8, 16, minus 32. That's not so bad. Now what do I do? I'm going to subtract 3 from both sides. And what do you get? You get minus 7x equals minus 35. And then I'll divide both sides by minus 7. And what do you get? You get x equals 5. I put a box on it, but I still want to check it. Where do you check it? In the original statement. And let's say I said 5, right? So what do you get? You get, let's see what you get. The 5th root, I'm checking. Let's see, 3 minus 5 times 7 is 35, right? And that would be the 5th root of minus 32, minus 2. And that does work out. The 5th root of minus 32, at least at this level, is just simply minus 2. So it works out beautifully, right? The key tells us that that's true, by the way. All right, let's go to the next question, which is number 5, will be on the next page. And a lot of students, what happens to them is they really simply say, well, what you do is too much work and I don't want to do all that work. And then they get a wrong answer. And it doesn't really matter. It does matter. We're looking for the truth. All right. So someone says, I don't know what that means. I'm looking for the correct answer to the problem. And by the way, whether I get it by chance or not, I don't think that's what I'm looking for either. I'm looking, do you know what we've been talking about? And the first step over here, and this is going to be a bigger problem, by the way, there's no doubt about it. This problem over here for a lot of students is going to be much more difficult. And I'll tell you the number one reason it's going to be more difficult is looking at it, and put this over here. Sorry about that. I have to isolate the radical. There's 2 radicals now. Now, someone said, oh, the radicals are all on one side. There's 2 radicals there. I have to isolate a radical on one side. I think I can do it. I'll write this down for you. So I'm going to isolate this guy here. Whoops, sorry about that. I'm going to isolate this guy here. That means I've got to add the other radical to the other side. And I know it's going to look bad to you. Okay, a lot of students are going to say, I'm not going to do that. I'm going to do my technique. All right. Now, granted, I'm not saying you can't do your technique, but you have to start to realize that when you're doing something, it's probably not really well thought out at this point. However, over time, you might say to yourself, well, if I gave it a little bit more thought, maybe there is another way to do it. But let me point this out. We need to isolate a radical. And we've done that. Right? What are we going to do now? I'm going to raise both sides to the index of the radical, which is 2. Now, the left side is really easy to do. It's just this. The right side is more challenging for me. I'm going to write down what I mean by that. And again, this is where a lot of students argue, this is too much work for me. I do want to emphasize though, without an education, I would say that most jobs are really too much work. You're working all the time. I got to do some work here. 1 times 1 is 1. 1 times this thing is this thing. It's work too, right? Let's keep going. This thing times this. Well, that's not so bad. And yeah, it's a lot of work. This thing times this thing. Well, that's pretty simple. That's just simply 4x minus 7. I realize what some people are arguing now. This is so much work. I don't think I could go on anymore. Or this becomes so complicated, I can't finish. I think we can. Let's see what you get here. You get minus 6, right, because I did 1 minus 7, plus 4x, plus 2, square root of 4x minus 7. Oh boy, I got to do a lot more work here, don't I? So I'm going to subtract 4x from both sides. You may want to do, I'm trying to isolate the radical now. Add 6 to both sides. Let's see what you get. On the left side, you get 6. On the right side, you get 2 square root 4x minus 7. What I would recommend you do now is divide both sides by 2. Again, I'm looking to isolate the radical. And what do you get? 3. And yeah, it's a lot of work, right? Root of 4x minus 7. So I isolated that radical now. What am I going to do now? Raise both sides to the index, which is 2. What do you get? 9. 4x minus 7. Well, things are getting easier now. What do you got to do? Check. Let's check. Ooh, look at all that work. I said x is 4, right? That's what the key says. But you know what? I don't trust the key. I'm going to do this over here. I can see if that's true. Square root. Well, if x is 4, that'd be root 16. Minus, I'll write this one down. If x is 4, that's 16 minus 7, which is 9. What's square root of 16? 4. What's square root of 9? 3. Does 4 minus 3 equal 1? Of course it does. It works out beautifully. All right, let me repeat this for you. You just saw me do some problems. Your goal is to be able to do problems like that with the technique we described in class. What does that mean? You must start working on your own, doing things on your own, independent, all right? What kind of questions? Question that we prepare for you. There's also WebAssign. Don't do the WebAssign until you've attended lecture, listen to what we presented to you, and have done the homework that's embedded in the lecture notes. Then do the WebAssign. And the WebAssign should be very simple. Then when you get to the exams should also be very, very simple. Thank you for your attention.